Okay, so for the second part of the semester test review, remember that the first part is the 9 weeks test review, yeah? Okay, so we'll just get to it. When you're multiplying these two, you need to distribute the first term. So if I distribute the 4m cubed n to this one, well, you multiply the number with a number, and then when you multiply m cubed times m cubed, you have to add the powers. So m to the 6th, and n times n is n squared, plus, now multiplying this and this, 4 times 5 is 20. M cubed times m squared is m to the 5th, and n times n cubed is n to the 4th. And there's my final answer. Okay, on this one, if you multiply, you get 16x to the 6th, y to the 6th. So you add the powers, or you multiply 8 times 2, and add the powers 2 and 4, 5 and 1. Okay, 8 times 6 is 48, x squared times x squared is x to the 4th, y to the 5th times y cubed is y to the 8th, and then times this last one. So 8 times negative 5 is negative 40. X squared, there's no x over here, so x squared, y to the 5th times y squared is y to the 7th. Okay? On this one, you need to FOIL it out. So first I'm going to rewrite it as 6n minus 8 times 6n minus 8. And then we multiply. So I'm going to first I'm going to distribute the 6n. So 6n times 6n is 36n squared. 6n times negative 8 is negative 48n. And then I do the same thing with the negative 8. Negative 8 times times positive 6n is negative 48n. And then negative 8 times negative 8 is positive 64. Okay, the only thing I can combine are these two. So that's 36n squared minus 96n plus 64. And there's my final answer. Okay, so now let's do this one. Okay, if you're raising something to the third power, you have two different choices. You can use Pascal's triangle, or you can just FOIL it out. So I'll show you both ways. Okay, so first of all, if I was just multiplying negative 2k plus 7 times itself 3 times, what I would probably do is FOIL the last two, distribute, you multiply, and then distribute the first, okay? So I'm going to go ahead and multiply. So I've got negative 2k plus 7 times. Negative 2k times negative 2k is a positive 4k squared. Negative 2k times 7 is a negative 14k. And then I'm going to distribute 7. 7 times negative 2k is negative 14k, and 7 times 7 is 49. Okay, I can combine these two to negative 28k. So then what I'll do is distribute this to all three of those. So negative 2k times 4k squared. That's a negative k, or negative 8, sorry, negative 8k cubed. Negative 2k times a negative 28k is a positive 56k squared. And then negative 2k times 49 is a negative 98k. And then I'm going to distribute the 7. So I've got 7 times 4k squared, that's 28k squared. Okay, 7 times a negative 28k, 7 times negative 28, 56, so 196, 14, yeah. So it was a negative 196k, and then 7 times 49 is 343, pretty sure. 49 times 7, 7 times 9 is 63, 28. Oh, just kidding. That's funny. 49 times 7, 63. 7 times 4 is 28 plus 6 is 34. Okay, good. Alright, so then I'm going to add like terms. So negative 8k cubed. 56 plus 28 is 84k squared. Okay, and basically like adding 100, but you're subtracting 2, so negative 294k plus 343. And there you go. Okay. Now, the other option is to do, now, obviously, if you have a calculator, you're going to go a little bit faster. I was just doing it in my head. The other option is to use Pascal's triangle. So Pascal's triangle is 1, 1, 1, 1, 2, 1, because you're adding, right? So you always have the 1s on the outsides, and then these two added up together is 2. And then 1, 3, 3, and then 1. Okay, it's a power of 3, so we're on the 4th row, because this is the power of 0, degree of 1, degree of 2, degree of 3. Okay. So what you can do is just write out 1, 3, 3, 1. So 1, 3, 3, 1. And then you start filling in the terms. So the first term in this binomial is negative 2k. So going this way, I'm going to have negative 2k to the highest power, 3, and then go down. So negative 2k squared, and then negative 2k, and then no negative 2k. And then going backwards, well, going this way still, but just doing backwards powers. I start with 7 as a 0 power, so no 7 here, and then 7 to the first, and then 7 squared, and then 7 cubed. Okay? Well, if I look at this, a negative 2 cubed is a negative 8, and a k cubed is k cubed, times 1, just negative 8 cubed, 8k cubed. Okay, this is 3. Negative 2 squared is 4, so 3 times 4 times 7, or 21 times 4, that makes 84, so that's a positive 84k squared, because k is squared as well, which is what we had. And then I've got a negative 2k, so that's a negative 6 times 49, so if I do that to the side, 49 times 6, that's 54, that's 24, 29, 294. Yeah, we did. Okay. And it's negative, so negative 294k, and then plus 343, which is what we have. And like I said, if you have a calculator, then you're saying 3 times negative 2 times 7 squared. 3 times negative 2 squared is positive 4 times 7 to the first. Okay? Either way, you get the same answer. Now, I'm definitely going to use Pascal's triangle on this one. I'll show you both ways, but it's whatever you prefer. 1, 1. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So there's my row, power of 4, look for the 4, and there we go. So 1, 4, 6, 4, 1. Okay, so it's r plus 3, yeah? So the first term is r. So I've got r to the 4th, r cubed, r squared, r to the first, and no r. And then I've got 3. No 3, 3 to the first, 3 to the second, 3 cubed, and 3 to the 4th. Okay, and then I multiply. These are all plus signs because there's plus in between, and none of them are negative. Okay, so I've got r to the 4th plus 3 times 4 is 12, so 12r cubed, plus 3 squared is 9, 9 times 6 is 54, r squared, plus 3 cubed is 27, 27 times 4 is 108r, and then 3 to the 4th is 81. Okay, so now I'll show you the other way. The other way is to multiply r plus 3 out by itself 4 times. Okay, so you have a couple different ways to do this. One is to FOIL out 2, and then FOIL them out with each other. Or FOIL out 2, and then FOIL out another one, and then distribute another one. I should say distribute. I'm going to go ahead and just say r squared plus 3r plus 3r is plus 6r plus 9, and multiply that times itself. So that's those two as well. Okay, so r squared times r squared is r to the 4th. R squared times 6r is 6r cubed. R squared times 9 is 9r squared. Okay, now I'm going to distribute the 6r. So 6r times r squared is 6r cubed. 6r times 6r is 36r squared. 6r times 9 is 54r. And now I'm going to distribute the 9. 9 times r squared is 9r squared. 9 times 6r is 54r, and 9 times 9 is 81. And then we add like terms. So I've got r to the 4th plus 12r cubed. 36 is 9 times 4, so 9 times 4, 5, 6 is 54 r squared. And then 54 plus 54 is 108 r plus 81, which is the same thing that we got right there. Okay, so however you're more comfortable with. Alright, state if the given binomial is a factor of the given polynomial. So the easiest way to do that is to go ahead and do the division. And instead of doing long division, we might as well just do synthetic division. And then just see if you get a remainder. If you get a remainder, it's not a factor. If you don't get a remainder, then it is a factor. So in the synthetic division box, you have to remember to put the opposite of what this is. And we have 3, 13, negative 57, and negative 7. Bring down the 3 and multiply negative 21, add negative 8, multiply 56. Sorry, I'm kind of going to bring that down, and then you multiply and you get negative 21. Then you add these and you get negative 8. Then you multiply these and you get positive 56. Then you add, you get negative 1, multiply, you get positive 7, you get a remainder of 0. So is it a factor? Yes. There's no remainder. So on this one, I'm going to put negative 4 in the little box, put across the top 9, 41, 25, and 24. Bring down the 9 and multiply. So negative 36, and I get 5, negative 20, and I get 5, negative 20, and I get 4, so no. Okay, solve each equation. Okay, so when I'm trying to solve this equation right here, first I want to get the square root of 11, so I'm going to subtract 9. And you get 2 equals the square root of v plus 10. Now I want to get rid of the square root. How do you get rid of square root? You square. So I'm going to square this and square that. So I'm left with 4 equals v plus 10, subtract 10, and I get negative 6 equals v. Now, you always need to check your answers, just as remember to check for extraneous solutions. If you somehow get the square root of a negative number, that doesn't work. Or if you get a square root equal to a negative, that doesn't work. When I plug in a negative 6, that's the square root of positive 4, that's fine. Okay. So this one, again, I want to get rid of a square root, so I square both sides. When you square this side, you're left with negative 1 minus 8m, and you're left with 3m plus 10 on this side. And then you just need to combine like terms. So I'm going to add 8m and subtract 10. So negative 11 equals 11m, divide by 11, and you get m equals negative 1. If m equals negative 1, when I plug it back in here, I've got a negative 8 times a negative 1, which is a positive 8, making this a positive underneath the square root. A negative 3 plus 10 is a positive, so we're good. They're both square roots of 7, so it works. Okay? On this one, when you square this, you have to remember that you're squaring both sides, yeah? When you square both sides, you have to square this whole side. You can't square individual terms. So I'm left with 2r plus 17 equals r plus 1 times r plus 1, which is r squared, plus 1r plus 1r, so plus 2r plus 1. Now, normally I would say get everything on the same side as the r squared because it's quadratic and you need to solve. But this is a 2r and that's a 2r. So if I subtract 2r, they cancel out, which means I just have an r squared. I might as well just subtract 1 and get r squared alone. And how do you solve for r? You take the square root. When you take a square root, how many answers do you have? You have 2, plus and minus. So I have plus and minus 4 equals r. Okay, so remember I need to check for extraneous solutions. So my original equation says the square root of 2r plus 17 equals r plus 1. If I plug in positive 4, 2 times 4 is 8, 8 plus 17 is 25, square root of 25 equals 4 plus 1, 5, and that's true. Now the other option is negative 4. If I plug in a negative 4, I've got 2 times negative 4, which is negative 8. That's a positive 9, so the square root of 9 is 3. But over here, if I plug in a negative 4, I get negative 3, and that's not true. So, like I said, if you have a square root equal to a negative number, that doesn't work, so the negative is extraneous. Okay. This one, number 11. When I square both sides, I'm left with the square root of negative 15 plus 8x equals x squared. Okay, so I'm going to get everything on the same side as the quadratic. X squared minus 8x plus 15 equals 0. Okay, this is a quadratic. First to check if it factors. If it doesn't factor, then I'll do quadratic formula completing the square. Factors of 15 add up to negative 8. 1 and 15, 3 and 5, both negative, add up to, or give me negative 8. So x minus 3 and x minus 5. So my answers are 3 and 5. Okay. If I plug into 3, then I've got negative 15 plus 24, and that's 9. The square root of 9 is 3. That does work. If I plug in 5, I've got 40 minus 15 is 25. Square root of 25 is 5. Equals 5. That also works, so we're good. They're both my answers. Okay, let's talk about 12. In order to do 12, what you have to do is first simplify it. It makes your life a whole lot easier if you would simplify before you start rationalizing. Okay, the fact of the matter is that if I have a square root divided by a square root, that's the same thing as saying the square root of this divided by that. So it's the same thing as saying 1 over 4 times the square root of 4k over 12k, just 12k. 4 over 12, it simplifies to 1 over 3. K's cancel out, so I'm really just dealing with the square root of 1, which is 1. Well, okay, I'll write it down like this. The square root of 1 over 3. Which you can go back to splitting up as the square root of 1 over the square root of 3. Well, the square root of 1 is just 1. So I'm really just dealing with 1 over 4 square roots of 3. Now, I don't suggest you go through that process. I suggest you just remember that you can do that and say 4 and 12 is 3. K's cancel out. That's just 1. So 1 over 4 square roots of 3. As it is, how do you rationalize? You multiply top and bottom by the square root of 3. That's just 3. Square root of 3 squared. So my answer is square root of 3 over 4 times 3, which is 12. Okay, so let's do 13. Alright, see if anything simplifies. The only thing that actually does simplify is 1x up here with 1x down there, leaving me with 3. I can still simplify, though. This is square root. Let me actually address that for a second. I'm going to rewrite it, because some of you might have decided to do something different. Okay, so I'm going to keep going with this for a second. The square root of x cubed. Well, x cubed is the same thing as saying x squared times x. Agreed? What I can do is I can take the square root of x squared, that's just x, and then I have to leave x on the inside. Another way of thinking of it is, how many times does 2 go into 3? Once, with 1 left over. Okay? Either way, what I'm left with is the square root of 2 over 4x times the square root of 5x. Okay? In which case, I multiply top and bottom by the square root of 5x. Okay? Square root of 2 times square root of 5x is square root of 10x. Square root of 5x times square root of 5x is just 5x. That's the point. And then 5x times 4x is 20x squared. Okay. Could I have done it differently? Yes. And actually, it might have been a little bit easier. What's the square root of x to the fourth? Well, how many times does 2 go in 4? Twice. So I'm really just dealing with the square root of 2x over 4x squared times the square root of 5. So I just multiply top and bottom by square root of 5. Square root of 10x over 4 times 5, so 20x squared. So it's kind of up to you on how you want to do it. I feel like this is actually a little bit easier. I don't know if we would see that, or if you would see that before you just went ahead and simplified, but something to think about. Okay, inequalities. So if I'm trying to solve this inequality, just like in an equation, I need to get rid of a square root. How do I do that? I square. So I'm going to square this side and square that side. So I've got x plus 3 is less than 16. Well, I need to solve for x, so I'm going to subtract 3. X is less than 13. But I'm dealing with an inequality, and I'm dealing with square roots. Anytime you have an inequality and you have square roots, you have to deal with the fact that you're trying to say everything for which this is defined. Well, what I'm saying is, if it's less than 13, then it should work. But if I plug in a negative 5 right here, negative 5 plus 3 is negative 2, and the square root of negative 2 is imaginary. So it doesn't exist, much less be less than 4. So you have to remember, anytime you're dealing with an inequality with a quadratic, or not a quadratic, with a radical, you have to say what's on the inside. Only on even radicals. Has to be greater than or equal to 0. I don't care what this symbol is. I don't care what you're dealing with. Anything inside a radical needs to be greater than or equal to 0. So that means x needs to be greater than or equal to negative 3. So on my number line, here's negative 3, and I need to be greater than or equal to it. Here's 13, and I just need to be less than it, which is why I put a parenthesis. Okay, well, they're both defined in between the two. So I'm thinking negative 3 to 13 is my answer. Okay? Alright, so let's look at this one. I want to get rid of the radical, so I square both sides. So if I square this and square that, I'm left with 2x plus 1 needs to be less than or equal to x plus 7. So I then subtract x and get x, subtract 1 and get 6. Okay, so that's one thing I got going. But I got another couple things. 2x plus 1 needs to be greater than or equal to 0. If I subtract 1 and then divide by 2, x needs to be greater than or equal to 1/2, negative 1/2. Okay. But I also have one more thing going. If I have x plus 7, then that means x plus 7 needs to be greater than or equal to 0, which means x needs to be greater than or equal to negative 7. So on my number line, I've got 3 different things going on. Here's negative 7, here's negative 1/2, and here's 6. Okay, I need to be greater than or equal to negative 7. I need to be greater than or equal to negative 1/2, and I need to be less than or equal to 6. So where are all 3 defined? Only between those 3. See, all 3 of my lines, 1, 2, 3, are defined between the 3. I should have done this in a different color, so you can see. But anyway, so my final answer is between negative 1/2 and 6 is where the whole thing is defined. Okay. Now with a quadratic inequality, you have to remember, in order to get rid of the square, you have to take the square root. But how many answers do you have? You have 2. What do you do with the other one? So first, let's subtract 3. So I've got x squared is less than or equal to 1. Well, in order to get rid of a square root, I square. But when I square, I have 2 answers. But you can't write less than or equal to both positive and negative, which is why what you have to do is put the positive on this side, repeat the symbol, and put the negative on this side. Okay, does that make sense? Is negative 1 less than positive 1? If it does, then your answer is between them. Okay? And I can check. Give me something between negative 1 and 1 is 0. 0 squared plus 3 is less than or equal to 4. That makes sense. But anything bigger than 1, like 2, 2 squared is 4, 4 plus 3 is 7, 7 is not less than or equal to 4. So it makes sense. Okay. So on 17, again, I need to get rid of a square by taking the square root. But when I take the square root, I got to put the negative on the other side. So I'm going to have x plus 3 is greater than 3. Repeat the symbol on this side and put the negative. Okay. Well, I want to get rid of this 3, so I'm going to subtract 3. So I've got negative 6 is greater than x, which is greater than 0. And does that make sense? Is negative 6 greater than 0? No. And if you read this, it says x is greater than 0, and x is less than negative 6. So it's split up. If it makes sense, they're together, or it's between the two. If it doesn't make sense, they're split up. Okay, on either side of these. Okay, 18. Alright, so we got a quadratic, and I want to know when is it less than 2. Well, what I would do is, normally I would say subtract 2, but, well, I'll go ahead and do that, okay. I'm going to go ahead and subtract 2. So I've got negative x squared plus x plus 12 is less than 0. Okay, I've got a negative with my quadratic. You can deal with it. You can factor out the negative. You can divide it out. But you have to remember what to deal with it, or what to do depending on what you do with it. If you factor it out and leave it there, then you have to remember you're dealing with a negative quadratic, so it opens down. If you get rid of it, then you have to remember to divide by a negative 1. Means you need to flip the sign. So x squared minus x minus 12 is greater than 0. Okay? So now, the only thing you can do, you can't like get x by itself. You can solve though by factoring. So I'm going to factor this. Okay, so I'm Move it. Okay, factors of negative 12 that add up to negative 1, negative 4, positive 3. Which means my answers are positive 4 and negative 3. Answers being when this equals 0, not when it's greater than 0. So here's what I know. I know that I have a quadratic, a positive quadratic, that crosses the x-axis at negative 3 and positive 4. So when is it greater than 0? Greater than 0 means to be above the x-axis, to be positive. Well, the y values are positive up here until it hits negative 3, it's 0, and then it goes down below, and it's negative. It's negative, and it's negative, it's 0 here, and then it picks back up here and does that. Well, if it said equal to, then I would include negative 3 and 4. But since it just says greater than, all I'm going to say is this parabola is greater than 0 from negative infinity leading up to negative 3, not including it because it doesn't equal to, picking back up at 4 and going to positive infinity. Now, if they had asked me when is this less than 0, it would have been between negative 3 and 4 because the y values are negative. Okay. Okay, so this one says determine the zeros and write the function in factor form. You have to remember that the multiplicity of a 0 determines how it crosses the x-axis. If you just think about y equals x, that's a linear function. It crosses through the x-axis, through the origin, and it just goes straight through it. If you think about y equals x squared, it equals 0 at 0, but it actually bounces off the graph. If you think about y equals x cubed, then it does cross through, but it crosses with a wave, yeah? So when I'm looking at these, right here, this is a 0, negative 3, and the multiplicity it looks like would be even. I'm going to go ahead and go with 2. This right here is a 0 of 1. With the multiplicity, well, it crosses straight through it, so it's 1. Now, I know it's a curve, but it doesn't wave like this one. So this one crosses through it 4, but it kind of waves through it like a cubic function, so I would say that the multiplicity is 3. So if I was writing this function in factor form, here's what I would say. If negative 3 is a 0, then x plus 3 is the factor. Multiplicity of 2 means power of 2. 1 is the 0, so x minus 1 is the factor, power of 1. You don't have to write the power of 1, but I did. 4 is the 0, so x plus, oh, just kidding, x minus 4 is the factor with a power of 3. And there you go. There's my function in factored form. Okay, indicate the initial value and whether or not the function represents growth or decay. If you have y equals a times b to the x, a is the initial value, because what happens is initial value is when x equals 0. Well, if x equals 0, a times b to the 0, anything to the 0 power other than 0 is 1. So you just get a. So that means when x is 0, the whole function equals a. Okay, so that's the initial value. This tells me whether or not we're talking about growth or decay. If this number is less than 1, or between 0 and 1, then it is decay. If it's greater than 1, then it's growth. So this right here, initial value is 3. Is it growth or decay? Well, 4 is bigger than 1, so I'm thinking growth. Initial value is 3 again, but this is smaller than 1, so I'm going to say this is decay. Initial value is 0.4. I don't really care about the fact that it's 0.4 as far as like determining growth or decay. I only look at this. So this is still growth because that's bigger than 1. Initial value 1/3, and this is decay because 1/4 is smaller than 1. Okay? Okay. You have to remember that when you have a this is the vertical stretch or compression. This is the horizontal stretch or compression. This is the horizontal shift left and right. This is the up and the down, the vertical shift. Okay. The horizontal stretch or horizontal compression always has to be factored out. It cannot be unless you distribute it, in which case the b and the c needs to be multiplied by each other. What I tend to do is just leave it in parentheses so you don't have to worry about that. Okay. So if I'm going to the left 5, then I need to have an x plus 5 on the inside. Remember, on the inside is the opposite. This is left and right. It has to do with x. Inside, opposite. Left, so plus. Horizontal, inside, stretch by a factor of 3. If it's a stretch, you got to think inside opposite, so not 3, but 1/3. Reflected over the x-axis, well, that's dealing with the y values. It's taking the y values and flipping them this way. Y values on the outside, so that's a negative on the outside. So f of x equals. Okay. Or I guess I can say the transformed f of x, so g of x. Okay, on this one, a horizontal compression by a factor of 1/2. Horizontal is x, that's inside, that's opposite, so 2x. Reflected over the y-axis, okay, that's affecting, when you reflect over the y-axis, you're affecting the x values. So it's on the inside, that's a negative. Up 4, that's dealing with y values, so that's on the outside, which is exactly like it seems, plus 4. Okay, now this one has it all. I've got right 10, inside, opposite. Horizontal stretch, inside, opposite, so 1/8. Reflected over the x and the y. Well, that's easy, you just gotta remember they're both negative. So x is on the outside, y is on the inside. Vertical stretch by a factor of 8, that's outside, so it's exactly as it seems. And then down 7, outside, so -7. There you go. Okay, so now let's talk about factoring. I'm actually going to go ahead and I'm going to take this one step further, just in case I ask you this on the test, because I might be inclined to. Factor and solve. So this is going to take a little bit longer, because we're going to factor and solve. Should be fun. Okay. X to the 4th plus 10x squared plus 9. What you have to realize is that this is the quadratic form. Doesn't look, I mean, it kind of looks like it, but as far as like how to factor it as if this is x squared and this is x. So the factors of 9 that add up to 10, 9 and 1. It's just that because it was x to the 4th and x squared, they're both x squared. And it makes sense. If I multiply these two, I get x to the 4th. 1x squared plus 9x squared is 10x squared plus 9. So it works. Okay, so I'm asking you to factor and solve. Well, these don't, they don't factor in the common sense. They can factor in that you can put your answers in factor form. But if I were asking you to solve, then you could say x squared plus 9 equals 0. So x squared equals -9. Take the square root, and the square root of -9 is 3i. So I've got plus and minus 3i. Well, now I'm going to solve this one. X squared plus 1 equals 0. X squared equals -1, so x equals plus or minus the square root of -1, which means plus or minus 1i. Okay. So technically, if I asked you to write this in factor form, then you could say x plus 3i, x minus 3i, x plus I, x minus I. And that would be the same thing. Okay? As that in factor form. So let's do 25. Now this one is a cubic, and it's got 4 terms, which makes me think I need to factor by grouping. So I'm going to group the first 2, group the last 2, and put a plus sign, because I have to carry the negative with it. What can I factor out? I can factor out an x squared. What am I left with? X plus 4. What can I factor out of these 2? A negative. So a -1, x plus 4. Because these are the same, I can factor it out. When you factor it out, you just put one of them. And then you've got x squared minus 1. Okay. Now, these didn't factor in the normal sense because it was not a difference of perfect squares, it was a sum of perfect squares. This is the difference of perfect squares. They do factor. So this is x plus 4, and x plus 1, and x minus 1. If you were unsure, take it out to the side and solve. X squared minus 1. X squared equals 1. X equals plus or minus 1. So plus 1 minus 1. Okay. So my answers are -4, -1, +1. Okay. Let's do 26. Now 26 requires you remembering the sum and difference of perfect cubes. So a cubed plus b cubed equals a plus b times a squared minus, is it 2ab or ab? Minus ab plus b squared. Let me make sure real quick. a cubed minus a squared b. Yeah, that's right. Okay. So, this right here, if this is plus, this is minus, that's always plus. If this is plus, this is plus, this is minus, this is always plus. If this is minus, this is minus, this is plus, this is always plus. So if it was a cubed minus b cubed, it would be a minus b, a squared plus ab plus b squared. Okay. As it is, we're dealing with the sum. So what is 64? Well, 64 is 4 cubed. So a is x and b is 4. Okay, so I've got x plus 4, x squared, the first one squared, minus the 2 times each other, 4 times x, and then the last one, plus 16. And that is that factor. Okay, as far as solving, when does that equal 0? Negative 4. This does not factor. If it did, then we wouldn't have this formula up here. Since it doesn't factor, you have a couple options. You can solve using the quadratic formula or completing the square. I'm going to go ahead and do complete the square first, and then I'll do quadratic formula. So to complete the square, first you need to add, yeah, you need to add, sorry, I'm kind of drawing blanks. So I'm going to minus 16 over here. Or I'm thinking about something. Okay, to complete the square, you need to divide that by 2. When you divide that by 2, that's what goes inside the perfect square. Well, in order to make this a complete square, you need to, as if this was FOILed out, x minus 2 times x minus 2 is x squared minus 2x minus 2x, which is minus 4x, plus 4. Well, I need to make that a plus 4, but I can't just add 4 to one side. I've got to add it to both. So that's negative 12. Okay, so now I've got x minus 2 squared equals negative 12. Well, I'm going to get rid of the square by taking the square root. So x minus 2 equals plus or minus the square root of negative 12. And then I'm going to solve for x by adding 2. Now, I'm going to go ahead and simplify this square root of negative 12. 12 is 4 times 3. Yeah? Square root of 4 is 2. Square root of negative 4 is 2i. So I'm going to say 2 square roots of 3 and then an I. I always put the i's on the outside. Okay. So if I were asking for the answers, you would say negative 4 and then 2 plus or minus 2 square roots of 3i. Quadratic formula, same deal. If I'm trying to solve x squared minus 4x plus 16 equals 0 with the quadratic formula, then I'm going to do this. Now first, let's remember what it is. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. And that's solving ax squared plus bx plus c. It makes sense. They go in alphabetical order. Please don't mess that up. So, a is 1, b is negative 4, c is 16. X equals opposite b plus or minus the square root of b squared. Negative 4 squared is 16. Not negative 16. Minus 4 times a, 1 times c, 16, all over 2 times a, which is 1. Okay. I'm going to do a little bit of magic because I can. 1 16 minus 4 16s is negative 3 16. So I'm going to say negative 3 times 16 over 2. Instead of multiplying out 4 times 16, let's say 16 minus 4 times 16. I'm just going to go ahead and say what that is. The square root of 14 is 4. A negative makes an I, so 4 plus or minus 4 square roots of 3i all over 2. 4 simplify with the 2. So 2 plus or minus 2 square roots of 3i, which is what we got up here. Okay? However you're comfortable finding it. Well, that took forever. Okay, now let's talk about 27. 27 is again factored by grouping. So I'm going to group the first 2, group the last 2, and then I'm going to factor out an x squared. So I've got x plus 5. Factor out a negative 3, x plus 5. Factor out an x plus 5, and I'm left with x squared minus 3. So, how do I solve? This is not a difference of perfect squares, but it still does factor. I could say x equals negative 5 and plus or minus the square root of 3. If I want to make sure on that, set it equals 0 and solve. X squared equals 3, x equals plus or minus the square root of 3. basically, if you have x squared minus any number, if it's 16, it's easy. It's x plus 4, x minus 4. But if it's 15, then it's x plus the square root of 15, x minus the square root of 15. Same thing, it's just that the square root of 16 happens to be pretty. Okay. 28. 28 is similar to 24, so let's factor this as if it was a quadratic. Let's see, there's some more space. Okay. So I want the factors of negative 35 that add up to negative 2. I'm thinking negative 7 and positive 5. Okay. This, x plus the square root of 7, x minus the square root of 7, or x squared minus 7 equals 0, when x squared equals 7, so x equals plus or minus the square root of 7. When does x squared plus 5 equal 0? When x squared equals negative 5, or when x equals plus or minus the square root of negative 5, or plus or minus the square root of 5, I. 4 answers. There we go. Which corresponds to the power 4. Okay, last one, similar. X squared factors of negative 36 that add up to negative 5. I'm thinking negative 9 and positive 4. Okay, this one factors to x plus 3x minus 3. Do I have to be able to do that in order to find the answers? I don't know if I did that. No. I could just say set it equals 0 and solve, plus or minus 3. This one, how do you solve? Well, it's not a difference, but it is perfect squares. It's just 2i, because if I set this equal to 0 and solve, I have to subtract 4. So I'm taking the square root of negative 4, which is plus or minus 2i. Okay? Alright, the algebra training, so I'm just going to finish the other ones in a minute, and I'll post that with it, okay? Or next to it.